Right. This is a continuation of examples on tangents and normals. We in the previous video did examples A, B, C, and D. We are going to start with E here, where we have got y equals to inverse tangent x and want to find the gradient or the equation of the tangent when x is equals to 1. As before, we're going to start by finding the derivative, and derivative of inverse tangent is 1 over 1 plus x squared. Then the next thing, we want to find the point of tangency, so we are going to plug in 1 here. So we're going to do one inverse tangent of 1. We can actually do this in the calculator. First, going to do it in the in degrees, but then we are going to recall that so this is saying 45 degrees, but in calculus we always want our degrees in radians. So just going to put the calculator in radians, in the radians mode, and then this gives us that, but so it's probably just easier to convert this one because we want the exact value. So we're just going to convert the 45. We know that 45 degrees is pi on 4, so it's going to be pi on 4 here. So that means the point of tangents is 1 pi on 4. Then for the gradient, we're going to plug 1 into the derivative, so it's going to be 1 over 1 plus 1 squared, so it's going to be 1/2. So that is the gradient of the tangent. So the equation of the tangent is going to be y minus pi over 4 is equals to 1/2 x minus 1, got over 2 and over 4 here. So if we want to clear all the fractions, we can multiply by 4. Before y minus pi, it's going to be 2 into x minus 1. So 4y minus pi is 2x minus 2. So we can write this as 4y minus 2x is equals to pi minus 2. So that's going to be the equation of the tangent. For the normal, if we go back here and simply do negative reciprocal of that, so it's going to be y minus pi over 4 negative 2x minus 1. And then if we multiply by 4 again, 4y minus pi, it's going to be negative 8 now. So it's going to be 4y minus pi is 8 minus 8x. So if we bring 8x on to the left hand side, it's going to be 8 plus pi. Alright, in the last example, we've got x squared minus 3xy plus y squared equals to 5. We want the equation of the tangent when x is equal to 1. So for this one, we have to find the derivative implicitly. Okay, so if we differentiate here, x squared is going to give us 2x. Then here we're going to have to use the product rule, going to be y plus xy prime. I'd have to revise your implicit differentiation if you have to. So 2x minus 3y minus 3xy prime plus 2yy prime equals to 0. These are the two terms that involve y prime. So we're going to keep them on the left hand side. 2y minus 3x between these two terms, and these two terms we're going to take to the right hand side. So from here, y prime is going to be 3y minus 2x divided by 2y minus 3x. Okay, so that's the derivative. Then we need the point of tangency. So we are going to substitute x equals to 1 here. If you substitute x equals to 1 there, it's going to be 1 squared minus 3 times 1 times y plus y squared is equal to 5. Okay. So this is going to be y squared minus 3y minus 4 equal to 0. That's actually a quadratic. This we can factorize. It's going to be y minus 4 y plus 1 equals to 0. So that means there are going to be 2 points of tangents here. One of them is going to be y equals to 4. The other one is going to be y equals to -1. We're just going to work through this one. The calculations will be exactly the same for the case when y is -1. So 1, 4 is the point of tangency. Then we will need to find the gradient of the function or the tangent. So we're going to substitute that one here. So we need to substitute x equals to 1, y equals to 4. So we go here, let me just write it out. So it's 3y minus 2x over 2y minus 3x, 2y minus 3x. So we are going to substitute 1, 4. So that's the notation when you've got an expression and you want to substitute. So x equals to 1, y is equals to 4. X equals to 1, y equals to 4. So in the numerator we're going to have 12 minus 2. In the denominator we're going to have 8 minus 3. So the gradient is going to be 2. Then the rest is as before. So x is 1, y is 4. So that means the equation of the tangent is going to be y minus 4 equals to 2 into x minus 1. Y minus 4 is 2x minus 2. So y is going to be 2x plus 2. And then for the normal, we're going to have y minus 4 is equals to -1/2 x minus 1. Bring the 2 to the left hand side. So this is going to be 2y plus x is equal to 9. So that's going to be the equation of the normal. Okay.